Okay, so the first problem is a 2D moment, not 2D moment, 2D vector resultant force and also dot product problems. So this one problems I separate into three parts and because that's typically the way that how he will ask you guys in a free response problem. So problem says from the image below, part A, determine the magnitude and the coordinate direction angle of the resultant force. Okay, so first thing what we have to do, we can tell that this is not position vector problem. It's a coordinate direction angle problem. So first thing we have to do is that we need to find out the F1 and F2 components. So we know that this is my F1. Okay. Please excuse my drawings. This is F1, and this is F1Z, and this is F1 prime, and this is the projected plane, which is 20 degree here. - 35 degree here. Okay, so we know that F1Z, that's going to be equal to F1 cosine of 35, and F1 prime, that's equal to F1 sine of 35. And then F1 prime, it can separate into the X and Y, right? Okay, so you look at it, this will be F1X, this will be F1Y. Okay, so F1X will be equal to F1 prime cosine of 20, and F1Y prime equal to F1 prime sine of 20. Okay, and this is how you would do a projection angle kind of plane. But if you guys are unfamiliar with this topic, please go back and review my SI session number 2, I guess. I guess in that SI section, I explain this more in detail. So we know that F1 is equal to 400, as I stated right here. So we can write this out. So F1 equal to 400 sine of 35, cosine of 35, which is the X. Oh, not cosine of 35, cosine of 20. Plus, this one should be negative. Because as you guys can see from this image right here, Y is going into negative Y direction, right? So this should be negative right here. So minus 400. Sine of 35, sine of 20. All right, and then plus my F1Z, which is a 400 cosine of 35. All right, and then if you put this in the calculator, you can get an F1 is equal to 215.6 I, which I should have it here, minus 78.5 J plus 327.5 K. Okay, so I have my F1. I found out my F1 in Cartesian vector form. Next thing I have to do is I find my F2. I know that my F2 is the coordinate direction angle. So my F2, we know that I will have to apply F2 vector equal to cosine alpha plus cosine beta plus cosine gamma. And what's my alpha, beta, and gamma? Okay, so let's look at it. So I know that my alpha is from the positive x-axis to F2, which is this 45 right here, see? And my gamma was from the positive y, which is 60 right here. And then my beta will be 60, and then my gamma is from the positive z-axis to the F2. Okay, so alpha, beta, and gamma is always where the positive XC is 2F2. So positive X is right here. So, and then the angle between positive X and F2 is 45, right? And then the angle between positive Y and F2 is 60, right? And the angle between positive Z and F2 is 120, right? So that's how I determine alpha, beta, and gamma for my F2. And F2 is giving, F2 is also 400. So 400 cosine of 45 I plus cosine of 60J plus cosine of 120K. Okay, and then basically just distribute them and I get my F2 vector will be equal to 282.8 I plus 200J minus 200K. Okay, all right. And then my FR will be simply just equal to my F1 plus F2. Okay, which just so sum them all together. So I have my 215.6 plus 282.8. And get 498.4 I, and then do the same thing for Y and Z plus 121.5 J plus 127.7 K. Okay. This is my FR, but this is my FR vector. So this is my FR vector. And the problem is asking us to find the magnitude of the FR. So magnitude of FR, we know them, square them, and then take a square root of them. Again, 528.65. Okay, so I found part of, so I answered part of part A. And then the second part A asks, do you find the coordinate direction angle of the resultant force? Okay, so this time we need to find the coordinate direction angle for the resultant force. This step right here, we are finding the coordinate direction angle specifically just for F2. Okay, so I need to find my alpha, beta, and gamma. Alpha is equal to cosine inverse of my 498.4 divided by the resultant force, which is 528.65. That's 19.5. Same thing for beta and gamma. I'm not going to write it. I'm just going to write the answer. So for beta, we get 76.7, and now gamma, we get 76 degrees. Okay. And you guys all know that alpha, beta, and gamma is just basically just the FR of that component, which for alpha will be FRX divided by FR. For beta, FRY divided by FR, which FRY is right here. Okay. Not going to go into too much detail about this because you guys should know how to do it at this point. And then part B, oh, let me shrink this down. That's why part B, let me use a different color. So for part B, it's asking to determine the angle between two cables attached to posts. Okay, so we need to determine the angle between these two angles. Okay, which we're going to use this formula right here. Okay, so theta, and this process right here is that's what it's called dot product. Okay, so theta is equal to F1 vector multiplied by F2 vector, and then the magnitude of F1 and F2 vector. The theta equal to 215.6 multiplied by what's my F2x of 282.8 plus negative 78.5 multiplied by 121.5 plus 327.7 multiplied by negative 200 over F1 by F2 F1 multiplied by F2 result. F1 multiplied by F2 magnitude. Okay, I haven't found them yet, so let's do a quick calculation. So F1 magnitude, if I just square this F1 vector and take a square root of them, I get my F1 will be equal to 400. And then for my F2, I'll get 400 as well. So 400 multiplied by 400. This theta equal to cosine inverse. My bad. Okay, so do this calculation and you will get theta will be equal to 97.28. Okay. And then the part C is asking, determine the magnitude and projected component of F1 along the line of F2. Okay, so how are we going to do that? So F1 is going like that. So project it along the line of F2. It's very simple. That's just going to be F1 projected equal to F1 cosine of theta. Okay, and then which the angle that we found is 97.28. So we get 400 cosine of 97.28. F1 projected will be equal to 50.67 newtons. Okay, so that's all for the first problem. Like I said, this will be a typical way he will ask you guys for this kind of first source problem. Okay, so problem 2 is also a 2D vector problem with dot product, but this time I change it a little bit. We don't have to take angles into consideration at this time. Well, this will be a projection vector, a unit vector problem. Okay, problem 2, part A is asking us to determine the position vector and unit vector of FAB and FAC. Okay, so we know that for this kind of problem, first thing we have to do is to find out the coordinates for each point. So let's do that. So for A, I have 0, 0, 36, because it's only 36 feet along the z-axis and nothing along the x and y. For B, I have 18, negative 12, and 0. And then for C is a little bit different. C, as you can see right here, it's 12 feet right here, and the angle given is 30 feet. We know that along the y, it will be 12 cosine 30, and then along the x, it will be 12 sine 30, right? And then they are both positive. And then first thing we need to do is that in order to find out FAB, first thing is RAB vector, and then magnitude of RAB, and then unit vector of RAB, and then force vector of AB will be equal to FAB magnitude multiplied by unit vector of RAB. Okay, so this is the process. So next thing, we know that RAB vector equal to RB minus RA, which that'll be 18, negative 12, and negative 36. Magnitude of RAB will be equal to 42. Okay, same thing for RAC. So RAC RC minus RA, which that'll be equal to 12 sine of 30, 12 cosine 30, and 0. Magnitude of that will be equal to 37.95 feet. Okay, so my UAB equal to RAB vector divided by magnitude of RAB, which will be 18 minus 12 minus 36 over 42. I get 3 over 7i minus 2 over 7j minus 6 over 7k. Okay, and then for UAC, same thing. 12 sine 30 plus 12 cosine 30 minus 0 over 37.95. My UAC is 0.151 0.1581 I plus 0.2739 J plus minus my bad. This shouldn't be 0. This should be negative 36 because it's a C minus A. Negative 36 here. Okay, so I answered part of I answer all part A because part A says to determine the position vector and unit vector of FAB and FAC. So here's the unit vector of AC. Here's the unit vector of AB. Here's the position vector of AB and the position vector for AC. Part B, the problem is to determine the magnitude of the projected component FAB acting along the z-axis. In order to do that, we need to find out what's the vector of FAB. We know that vector of FAB will be equal to FAB multiplied by unit vector of AB, which the magnitude of FAB is 700 pounds, multiplied by the unit vector of AB right here, 3 over 7i minus 2 over 7j minus 6 over 7k. FAB equal to 300i minus 200j minus 600k. And then don't forget the units, it's pound. Okay, and then next, we haven't done yet. The problem is that projected along the z-axis. So we have to take this thing, multiply by the z component of k. Okay, and then k, that's simply just 1k vector. So just one. So FAB along the z-axis will be equal to FAB vector multiplied by k. Will be equal to 300i minus 200j minus 600k multiplied by 1k. And then these two are gone because it's only acting along the z-axis as it's staying problem. So we don't have to take the x and y axis into consideration. So simply just take 1k multiplied by 600, negative 600k. So I get my FAB along the z-axis will be equal to negative 600 pound. And then this k and k, they cancel out. Okay. So that's all for problem number 2. And I'll see you guys in problem number 3.